Good morning to all. Let me test before starting. Can you hear my voice? Can you see the file on the screen? Okay, thank you. I uploaded a file on Google Classroom, which includes this week's questions. Please download that file before starting. Let me repeat again for the newcomers. Please download the file on Google Classroom. Okay, we are going to solve those questions. Are you done? Did you reach the file? Did you get the file? Did you get the file? How about the others? Okay, okay. Thank you very much. And we are going to solve these questions today. Okay, did you complete black box testing? I guess you completed black box testing with Boran Hoca. Am I correct? Am I correct? Okay, how about white box testing? Did you complete all the slides? You also completed white box testing. Am I correct? You completed black box testing and white box testing. Okay, thank you very much for your feedback. And as you can remember, last week we solved many nice questions related to black box testing. This week, actually, we will continue solving questions related to black box testing. Okay, and I collected some other questions from final exams. I look at all over the final exams. Okay, I collected these questions. Okay, we are going to solve these questions. If we have time at the second hour, we will start white box testing. But if we don't have enough time, then we will start white box testing questions next week. Okay. And during this time, I guess you got the file, you download the file, okay? And we will start with the first question. Let me read. Your project manager encourages you. Encourage means in Turkish, cesaretlendirmek, motive etmek, and your teammates for a software design with rather small components. Uh, Maybe you can remember that we solved the same question with large components, and but the same question with small component statement is another final exam question. Let's solve this question this week. And small components for the current project. A part, what is in your opinion the system property that the customer puts most value on? So you are expected to select a non-functional system property, okay? And performance, reliability, sustainability, usability, etc., etc. And B part, justify your answer at most 4 sentence paragraph. Okay. Before discussing this question altogether, I want you take your own notes like in exam. Okay, so, self practice. Okay. And you have approximately 1 minute, 2 minutes. Okay, and then we are going to discuss this question all together. Actually, that's why I sent you an editable file. I want you to take your own notes in this file, okay? If you want, you can also use your paper, pen, pencil, okay? Okay, I guess you are done. Let's discuss it. Okay. Your project manager encourages you and your teammates for a software design with rather small components for the current project. And we are expected to find the non-functional property, system property that the customer puts most value on. Okay. We are expected to find the highest priority non-functional property from the point of customer, okay? And since the customer wants small components instead of large components, maintainability is actually the system property that the customer wants to put most value on. Why? Because let's read the B part. A maintainable software system is one that provides for easy localization of potential bugs. Okay, this is actually the key part of the answer. To easily locate bugs, such a system should be built modularly, okay, where each module is compact as possible and fulfills a meaningful functionality. And in other words, if you have a maintainable architecture, this means that you have a modular modular architecture, okay? And this also means that it will be easier for you to find potential bugs, to find the required functionality. Okay, and this is the main part of maintainability. Okay, and did you understand this answer? Do you remember the question that we solved with large components? Performance is the system property that the customer puts most value on in that case, in large component case. Okay, because we were talking about the communication costs between the components in the architecture. Okay, but this time, if we have a small component, then this means that maintainability, having a modular system, is the most important system non-functional property. Okay, did you understand the answer? Please take your own notes. Okay, I guess you completed your notes. Okay, okay. Let's continue with the second question. How would you write a verifiable usability requirement? Please solve second and third question together. Okay. How would you write a verifiable performance requirement? Actually, B part, we mentioned about B part nearly 2 weeks ago, okay? But we are going to repeat it since it's a popular question in this course final exams, okay? So you have three questions, okay? These three questions, and you have 3 minutes. Okay, let's start. How would you write a verifiable usability requirement? Okay, usability means remember your last homework of the project. You are expected to uh, create your graphical user interfaces of your project. Okay, and user being user friendly is one of the most important properties of screens, okay, graphical user interfaces, okay, and usability is important from the point of the customer, okay, because customer needs to use your system, your product easily, okay, and we can measure this usability requirement using number of health frames, training time. Maybe I mentioned you several years ago. I took a software measurement course, and we were busy with these kinds of measurement techniques. Okay, it's a very nice course, software measurement. Okay, and let's continue. How would you write a verifiable performance requirement? I guess you completed this answer in a correct way. It's very easy. If we are talking about performance, of course, we need to measure, we need to record process transactions per second. Okay, that is the most important thing, or user event response time. We need to measure the response time. Okay. And how about the last part, platform independence? Actually, we mentioned about it. Let me repeat it. An assessment criterion of platform independence of a software product is the amount of target dependent code. What is a target dependent code? Target and platform here means specific operating system or hardware, or maybe database, okay, something like that. And the question is asking that how would you improve platform independence, okay? Improving platform independence, okay? Increasing platform independence while increasing or decreasing the amount of target dependent code, or okay, this is the question, and you need to choose one of them. Okay, let's remember what is target dependent code. Target dependent code means writing code for a specific operating system or hardware. Okay, and writing target dependent code for operating system one, writing target dependent code for operating system two, writing target defined code for hardware type 1 or hardware type 3 goes on like that, okay? And if you have more target dependent code, this means that your product can run with more platform, okay, more with more platform. So in other words, this means that the more target dependent code, the more platform independent the system, okay. And let's read the remaining part. More target dependent code means a larger variety of platforms, as we mentioned, are defined and made compatible in the software system. The system can run on a larger number of platforms, hence the system is more platform independent. Okay, okay. Any problem? No problem, no question. Then let us continue. Okay. And for question, you have 1 minute. Okay. Okay, I guess you remember the answer. And in order to have a stateful behavior of a stateless software system, instead of keeping a big log file on the server, what is other solution that we discuss in case? Right, two disadvantages about it. The solution is, you remember, cookies. We covered lecture about cookies, types of cookies, the reason that cookies are using, advantages, disadvantages about cookies. And in the question, it is asking disadvantages of cookies. Remember that we were talking about three main disadvantages, three main problems about cookies. Uh, First one is about portability, because we know that cookies are not portable. And the second one is about limited space, because we know that cookies are stored on the client's side, okay, not on the server side. And so the capacity of space on the client side is a restriction, is a problem about cookies. And the third problem about cookies is about privacy issues, because some authorities actually reject cookies. Okay, I guess you remember these concepts from our lecture about cookies. Okay, okay, let's continue with the following question. Yes, I'm talking about question number 5. Okay, it's a question about throw away prototype system. Please read the question and note your answer. You have 3 minutes. Okay, you have 3 minutes. By the way, am I slow or fast for you? Uh, can you take your notes? Because this time I'm not going to send this answers file. Only the students who participate the lecture can see the answers. Okay, I'm not going to send the answers file. Okay, question number 5. You have 3 minutes. Okay, ladies and gentlemen, let's start. You have developed a throw-away prototype system for a client, not the full finish product, just throw-away prototype system for a client who is very happy with it. However, the customer suggested there is no need to develop another system, but that you should deliver the prototype and offer an excellent price for it. Okay, we are not talking about the finish, the full product. Okay, we are just talking about throw away prototype system. Pay attention on that, please. What is the main potential problem that may arise? Commanding detail. Okay. And the main problem is to maintain such a system. Actually, we don't have a finished engineered product. Okay, we just have a throw away prototype system, and so maintainability will be a serious problem. Okay, in the long term, the prototype is likely to be much more expensive to maintain because that is not finished actually, and maybe reliable as the engineered may not be reliable as the engineered system. That's just a prototype, okay? Just a prototype what the customer has now. And there are problems, actually, there are no problems in delivering the prototype. If the customer wants, then that's okay. Actually, we can deliver the prototype. However, as a professional developer team, we need to clearly state the customer that the maintainability will be a problem and will be much more costly. Okay, if possible, you should try to quantify maintenance costs which are likely to be involved and warn the customer of the short lifetime of the system. You may wish to draw up some written agreement that you make clear that you don't take responsibility for system problems. Okay? And from the point of maintainability, uh, delivering prototype instead of full finish engineered product system uh, is problematic. Okay, did you understand? Please take your own notes. Did you understand? Do you agree? Do you have any other idea? Please take your own notes. Are you done? Did you complete? You understood? No problem. Okay, let's continue with question number 6. Okay, question number 6. You have 3 minutes, ladies and gentlemen, okay? Please write your own answer, then we are going to discuss. Okay, let's see. The call return model is defined as a top-down subroutine model that should be familiar to you, where control starts at the top of subroutine hierarchy and through subroutine calls passes to lower levels in the tree. Would you choose to develop a real-time software system using call return model? Okay, the question is asking that would you choose to develop a real-time software system using this call return model or not? Okay, remember that in a real-time software system, response time actually is the most important thing. Okay, we need to make our architecture, we need to build our model based on response time, because response time is the most important thing in real-time software systems. Okay, and the answer is no, as you can guess. A call return model assumes a sequence of actions, whereas real-time systems must respond to events from different hardware interface to the system. And okay, that is requirement of responses highly likely to concurrent events. And in this top-down hierarchy, we have different modules with different hierarchy, okay? And taking response will get a longer and longer time. This is not suitable for real-time software system because response time must be very low, must be quick for real-time software systems. So this type of architecture is not suitable for real-time system. Okay, okay. How about question number 7? Please take your note. Yes, let's start. Question number 7 is asking what is the difference between a requirement that is not verifiable and not validatable? Okay, and a requirement that is not verifiable is one that is not expressed using some quantitative measures. And in actually, we cannot measure this requirement. In Turkish, it is ölçülemeyen. Okay. And how about the requirement that is not validatable? Okay, it is one kind of requirement that is expressed using some quantitative measures. Yes, we can measure this requirement, but empirically that is impossible or infeasible or very hard to validate them, since it requires maybe too many tests, maybe infinite number of tests. Okay, and so this is the main difference between a requirement that is not verifiable and not validatable. Please take your notes and ask your questions if you have questions. Complete your notes, please. Okay, let's give a 10 minutes break, then we will continue. Thank you very much.